Thank you, Madam Chair. And I do have a report submitted from CenterPoint Energy I'd like to get into the record.
Without objection.
Thank you. I'm fascinated by a couple things. The Mesonet system I was unaware of. Looks like there's 110 sites. Is this cellular based? Do we know? Dr. Moore, I guess that would be for you. You seem to know more. You see what I did there?
Yeah, set me up. Yes, it is, and we actually work with the Oklahoma State Patrol and their communication system to make sure that we have very fast information. Every 5 minutes it's updated, and that information then is available to anyone who logs on to the internet system.
And there is an app for it.
Yes.
Do you have that app on your phone?
Oh, yes, yes.
Okay, all right.
Everyone does.
Everyone does. I don't have it on my phone.
Come to Oklahoma.
Come to Oklahoma. That's North Texas, we call that. And Dr. Bostrom, you talked about the need to invest in social and behavioral sciences. What do you mean by that?
There's a broad range of sciences that can help us understand both management opportunities and how people undertake management opportunities. For example, if we think about EPIC, there's a lot of interest in community modeling and how EPIC can advance what we know about modeling the atmosphere. But it's very obvious from the discussions around EPIC that there are issues about how the community modeling itself should happen, what should be the procedures that guide it, and that kind of thing. There's a lot of research that can help inform what kinds of processes or methods for coordinating this could work better. There's also, of course, the obvious roles of behavioral and social sciences in improving communications and improving our understanding of how people assess their risks and act on them.
That's a pretty tall order because I've lived on the Texas Gulf Coast in a 20-mile radius 66 years, 8 months, and 26 days. Who's counting? And I've been through a whole lot of hurricanes. And you see from Hurricane Ike, which most of y'all would recognize, and then also obviously Hurricane Harvey and Tropical Storm Imelda was ground zero in mine and Dr. Babin's districts here in the last 2 years. And people don't take that serious when they say it's time to evacuate. And so we've got, if there's going to be some kind of certainty that we can come out with, how do you convince people? A lot of people evacuated, for example, during Rita and Katrina and some of the others, and the Houston highways were just absolutely inundated, pardon that use of the expression, and people couldn't get out, and there were several deaths on the highway, and they were running out of fuel and all kinds of stuff, and then a lot of them felt like they left needlessly. So how do you convince people through social and behavioral sciences that they can now trust our forecast? How do you get to that point?
There's evidence that people pay a lot of attention to warnings, and official warnings in particular, and that they're very important in influencing people's actions. People's actions are constrained not only by what they hear from the official warnings, but also by their own response opportunities, what they can afford.
Their own experiences.
Their own experience as well, and what their neighbors are doing. There's all kinds of influences. So just being able to persuade people that they should evacuate is not the only thing that's going on.
You mentioned that you study risk perception on page 1 in decision making.
Yes.
Who is your target audience when you study that?
Depends on the topic and the funding.
Okay, well, let's talk about storm decision making and evacuation and how much funding.
So a storm decision-making and evacuation, the only work that I've done on that has been in the context of flash flood and hurricane forecast and warning systems. And there we're looking, it was a National Science Foundation funded project. So our target was understanding what it was about the forecast and warning system that might be improved and how it might be improved in terms of providing accessible and available information to the different parties in the system to be able to make good decisions. So that meant looking both at emergency managers and what they need, as also as how broadcasters get information and how they use it to talk to people.
Sure. Okay, well, I need to move on. Just one more question for Dr. Shepard down here. When you're talking about predicting weather patterns and currents and inside of storms you talked about, you couldn't get to the eye wall there, couldn't get into those things. How do you, with any degree of reliability, predict wind currents and what the model airplane people call thermals, for example, stuff just came up from the Earth? How do you predict those?
Well, the atmosphere is a dynamic and thermodynamic system with moist processes in it. So our models actually can identify thermals in those processes. But what I was talking about, those thermals, if you will, in the eye wall of the hurricane, we can get information from the brave hurricane hunters that fly into those storms. There are satellite systems. I actually was the deputy project scientist for one when I spent 12 years at NASA, called the Global Precipitation Measurement Mission, or GPM. It actually has a radar in space, and so we can see something called hot towers, these bubbling thermals that you mentioned. And they provide clues that a lot of energy is being released in that hurricane, and we might see a strengthening of the storm. But here's the problem. That instrument is only on a polar orbiting satellite that only it gets a snapshot of the storm every now and then. So we need a generation of technology that's giving us more robust spatial coverage, perhaps a geosynchronous radar or a network of cube or small sat systems.
Okay, very quickly, I'm out of time, but when you said only gets a snapshot, those orbit the Earth every 3 hours, 6
So
hours?
polar orbiting satellites are in low Earth orbit, whereas our geosynchronous satellites are at about 35,000 kilometers up. So they're just staring at the same spot on the Earth the entire time. So a couple of times a day, perhaps, or it just depends on the type of orbit the satellite is in. So we don't always have that information. We need more sustained information like that, and that's really the value of some of the advanced observation systems that NASA is looking at in its decadal survey.
Thank you, Madam Chair. Thank you. I yield back.